Hello and welcome. This is Physics 2 Lab, Ohm's Law. Ohm's Law states that V, a voltage, is equal to a current, I, times a resistance, R. Today we're going to be measuring the resistance and through some resistors here in the lab. So the first step that we want to do is find out what resistor we're going to go ahead and use. In this case, we're looking at the third resistor down on our board, which is labeled as a 51 ohm resistor. To make sure, to double check that, we use what we call the coded resistance. In your lab handout, there will be a description of what the colored bands on the resistors mean, and you'll need to find what that resistance is and what its tolerance is. So this one here, the 51 ohm resistor that we are looking at, it starts with a blue band, followed by a red band, then a black band, and then a gold. And if you do the chart on the second page of the lab, you should get that that does come around to near a 51 ohm resistor with a tolerance. Read through to find what that resistance is, what the tolerance is, and record it in your Excel, since we'll be using that data later. Now for section 1, we've gone ahead and set up our layout just like they have in figure 3, where I have a power supply that's coming through an amp meter. The amp meter then supplies the power the rest of the way through to the board. This yellow jumper takes the positive terminal and connects it to our resistor, which is then fed through a voltmeter. And finally, the ground of that is brought around to the ground here, completing the circuit. Now I've set the voltage to about 1 volt, as you can see here with the voltmeter. The amp meter measures amps in millivolts, so this is important here that the amp meter runs millivolts or milliamps, so that when you do your conversion, you'll need to convert it back to amps. Okay, so right now it's 20 milliamps, so 0.02 amps. Okay, so finishing out this section, I'm going to go ahead and increase the voltage in 0.5 volt steps, and then we'll read what the amperage is at each of those steps. That will be given to you in your data sheet. Then we're going to form a plot with those points. Your plot should be linear, should be a pretty straight line. You'll be finding the slope of that line, and you should find that the slope is on the same level as the resistor that you're using. The slope is the resistance. So you should get around the 51 ohm. Next, you'll find the uncertainty in those measurements. It tells you how in the lab manual to find uncertainties. And then you'll want to compare those two values, the coded resistance with the bands and the resistance that you found on the slope. Okay. You're going to use those to answer the questions at the back of the lab manual. And one of the questions will be which is more precise, the color code or the measurement. Okay. Now we're going to go ahead and work on section 2. Okay, section 2 of Ohm's Law. We have discarded the multimeter for voltage and instead connected it to a Logger Pro voltage regulator. So this will give us the values of the voltages. We've done away with the other amp meter and have gotten a current sensor, also for Logger Pro. So now instead of taking points at every half a voltage and do it at the manual way, we'll do it through Logger Pro and see how that works. Okay, so if we come over to Logger Pro, it tells us our current and our potential. I will go ahead and increase this up to around 1 volt. So we get the same starting time, the same starting voltage. That's pretty close. And there's our current there. Okay. Now if I want to go ahead and hit collect and vary our voltage up to about 5 volts, you'll see that it is climbing. There's about 5 volts. Okay, so I'm going to go ahead and stop. Now what we want to do here is select a good portion of this line. Actually, all of this looks pretty good, so I'm going to select a very large portion of it. And we'll set that to a curve fit of just a linear line, the MI plus B. So we'll do a try fit, we'll hit OK. And we see that our slope on there is 50.94. Okay. So our slope is very close to the 51 ohm resistor that we wanted, and there's our uncertainty, 0.04134. Okay. After that, we're going to go ahead, just turn off the supply, turn everything down, and no need to print your plot. Okay. These are also questions to the back of the lab manual. Questions, I believe 2 and 3. Well, just 3. What is the slope for the values in 2.7? So these are the values that it's going to be provided for you. I'm going to try and screenshot and send this along with the data. Okay, we'll go on to section 3 next. Okay, for section 3, we have taken and moved the 51 ohm wires from the 51 ohm resistor up to a 10 ohm resistor, and we're just going to do the same scenario to see if it can measure that 10 ohm. Okay, so we'll go back over here to our Logger Pro, and we see that we're still at around 1 volt. We're going to collect this new data, and I will slowly turn this up to 5 volts. There's good. Okay, so we'll have to adjust our parameters here so that we're within good data. But you see there again, the slope is exactly where we would expect it to be. Here we're at 9.8 plus or minus 0.05. Okay, so these values here, they might not be exact to what you get in your data sheet, but they should be close to these numbers for the 2 different resistors. Okay. The color code for 3.5, they'll want to take the color code of this resistor and compare it to the stated values. So if you look at the 10 ohm, you can see that that is a red, black, black, gold. Okay? Red, black, black, gold. So figure out the resistor strength on that and compare the 2 values. All right, so here we are again for section 4 now. I've taken the wire leads and ran them through this small light bulb as per the instructions there in 4. So we'll see that light bulb turn on and get hot. We're going to go through a thermal circuit. Okay. So go ahead, head back over here to our Excel or our Logger Pro. I'm going to hit collect and I'm going to run it up to about 6 volts this time. Okay. Now I need to do this very, very slowly to get good data. Okay. Sorry for the shakiness. I have to hold the voltage over on one side while I also do this. But now you can see that it's no longer a really straight line. That the voltage, the resistance down here is different than the voltage or the resistance up here. So for parts 4.4 and ports 4.5, we're going to find that out. So at 4.4 we do the low currents. So I'm just going to select a spot of data that's down here on the low end. And I'll do a curve fit to that. And then I'm also going to select a bit up here on the high end, and I'll do another curve fit on that. And now you can see that the resistance of the low end is smaller than the resistance of the high end. Okay? An increase in resistance. These values are also be given to you on your Excel sheet And that'll take care of section 4. On to section 5. All right, last section 5. We're talking Ohm's law being violated through a Zener diode. So this here is a Zener diode. We've got it set up according to the documentation in the lab. You'll notice that the silver band on the Zener diode faces the positive side. These are directional. So what we're going to go ahead and do now is we're going to plot this and see that it is not a linear representation on Ohm's law. So anytime that it's not linear is when we have a violation of Ohm's law. Okay. So on our Logger Pro here, there we go. I'm going to get the voltage ready, and I'll go ahead and hit collect. And I'm going to range from around 0 volts up to about 4 volts. I'm going to try and do this as slow as possible. And you can see that it's climbing on the bottom. And then all of a sudden we hit something around 2 volts. And now it allows current to pass. And now this is interesting because even after I'm still raising voltage, it will not raise any more through it. It won't allow any more voltage to pass through it. Okay, we'll go ahead and stop. So here you can see that in the beginning we had no current passing through the diode until we hit about 2 volts of potential, and at that point it started to allow some in. And then here we have our linear representation afterward. It takes a while, and then it allows this through, and then it keeps this much potential going through it. Even if I continue to raise the voltage, it doesn't allow that much voltage to pass back through. It keeps it constant. Okay, so that's the other Ohm's law being violated. Now, that being the end of the lab, this one there is many questions to answer at the end, including some from this section, asking if the plot is a straight line. And you guys tell me, does that look straight or is that a big curve? And then there's some other ones in there that answer. I'm going to let you go ahead and put those in your lab reports.